So one more time, welcome everybody, and thank you for joining my session. Today, I'd like to present you some attack vectors and mitigations regarding AWS Lambda and serverless applications in general. But before that, please let me introduce myself. My name is Paweł Rzepa, and I work as a senior security consultant in Securing. On a daily basis, I perform cloud security assessments and penetration testing. You can find some of my articles as well as articles of my colleagues from Securing on our Medium blog. And from time to time, I also publish the latest news from the cloud security world. So if you are interested, I encourage you to follow me on Twitter and LinkedIn. All right, let's get started. First of all, AWS Lambda is a function as a service. It means that you don't have to worry about what server Lambda is running on because this is handled by a provider. So in this case, by Amazon. Thanks to Lambda functions, a developer can be focused only on providing the code, reducing the maintenance stuff to the minimum. The code execution is triggered by an event, and there are various event sources. For example, an event can be uploading a file to S3 bucket or an HTTP request to API gateway. The event triggers the Lambda runtime environment and executes the Lambda function code. Lambda functions work as a lightweight micro virtual machine based on Amazon Linux image. If you are interested to find out how does the Lambda environment looks like, you can visit lambdashell.com. The project gives you a shell to Lambda environment with, of course, some restrictions. So let me show you. For example, as you can see, the Lambda code is stored in var task directory. And here the Lambda code is in the index.js code file. But what is the most important from security point of view are the secrets which are stored in environment variables. Every instance of the Lambda function requires a role with assigned permissions, which is called the execution role. For example, every Lambda function needs privileges to put logs to CloudWatch service, or your Lambda to put or read an entry in DynamoDB. And this is done by assigned roles. The main character of the story which I'm going to present you today is Bob. Bob is a junior developer who has recently started programming serverless applications built with Lambda functions. His applications are developed in test environment and they will be used only internally. So absolutely nobody cares about any security testing or any special isolation of his code. Furthermore, Bob uses the most common serverless framework to deploy his applications in AWS. The serverless framework based on serverless configuration file, which generates the CloudFormation templates from which the application's resources are deployed in the cloud or rolled back. It also zips your Lambda functions with all the dependencies. All those steps can be, of course, done manually, but the serverless framework automates most of such steps and makes developers' life easier. All right, enough introduction. Let's take a look on Bob's first challenge. Files uploaded to the particular S3 bucket should be automatically renamed with some prefix. Pretty easy task. So the idea here is simple. Once the file named test_new_png is uploaded to S3 bucket, the event triggers the Lambda runtime environment. The event basically is a JSON file where you can find such information as name of the bucket or the name of the uploaded file. Then the Lambda is triggered and rename the uploaded file and remove the old one from the bucket. Hope it is clear and easy for everyone. Instead of writing the code from the scratch, Bob started searching for the ready-to-use code. So he searched through the internet, through the places like Stack Overflow or npm.js repository. And in npm.js repository, Bob found the package called s3 rename. Analyzing its usage, Bob found that it is exactly what he's looking for. That is, it renames the s3 file. So Bob writes the following code. As you can see, I will show you, he extracts from the event.json file the bucket name and the uploaded file name, and then add the prefix scanme to the name, and then all the magic is done by the s3 rename package. After uploading the file test new PNG, the scanme prefix is added to the file name. Moreover, even in the CloudWatch logs, everything seems to perfectly work. So Bob is super happy how easily and quickly he was able to finish his task. But when we analyze the s3 rename package, we'll see there's a line with obfuscated JavaScript code. This line of the code basically does the following. Verify if there is an environment variable called AWS access key ID, and if so, this access key ID is sent to the attacker's server, which is listening on port 8000, and then the access key ID is sent by in the key parameter. So, as you can see, I've received on my listening server, I've received the AWS access key ID here. To be honest, I've created the s3 rename package and published it just for the demo of this presentation. However, there was more than 500 downloads of this package, and on my server, I've received not only Bob's access key. And this is pretty scary because it shows me how easy it is to steal AWS keys. Of course, the s3 rename package is no longer available in the npm.js repository. Can we do anything to defend against such attacks? First of all, by default, Lambda is executed outside of your VPC, virtual private cloud. However, you can run VPC-enabled Lambda functions in private subnet. Using the security groups, you can control any outbound traffic. And if you need access to any of your resources inside of your VPC, you can do it via the VPC endpoints to communicate with them. Now, do such attacks happen in real life? Let me tell you the story about dependency poisoning in a very common NPM package, which is called the event stream. Event stream is kind of a toolkit to handle streams in your application. It is a very popular package with almost 2 million downloads weekly. And it is broadly used among many various applications. It was developed by and maintained by Dominic Tarr. Dominic is an experienced developer who's released many open source projects. 3.2 thousand followers, as well as the amount of his contributions to open source projects, seems to be a reasonable argument to trust this guy. But at the end of October in 2018, many developers who used event stream package in their applications started complaining that they are receiving the deprecation warnings regarding crypto methods, although they don't use any of the crypto methods in their applications at all. So the community started investigation. What the heck is going on? It was found that one of the event stream contributor with a nickname Write9Control added malicious code to the event stream. And Dominic Tarr replied. He emailed me and said he wanted to maintain the module, so I gave it to him. I don't get anything from maintaining this module, and I don't even use it anymore, and haven't for years. Let me repeat the scariest thing here. He emailed me. So as you can see, gaining permissions to push arbitrary code to the dependency used by thousands of other applications is as easy as sending an email with the direct request. So what malicious did Write9Control? For the first 12 days, nothing suspicious happened. Just the typical maintenance stuff like updating README file and some cosmetic changes. Then, the new dependency was added to the event stream with what was called the flatmap stream. The caret sign before the version of the dependency means use the latest compatible version of this dependency. The latest compatible version in semantic versioning means the latest minor or patch version which doesn't break core functionality. That means that once the event stream was updated to version 336, then the new flatmap stream in version 011 was pulled. All the dependents which updated the event stream package to the version 336 now contains the new malicious code from the flatmap stream in version 011. This is how flatmap stream looks like. The malicious code looked for the copay dash package, which uses the event stream as the dependency. Only when this package was found, the malicious code was decrypted and executed. The copay dash is a popular Bitcoin platform, so as you may already guessed, the goal of the malicious code was to steal Bitcoin wallets. The whole attack was uncovered for 48 days, and the only reason why it was detected was a sheer luck. One of the methods used by flatmap stream was deprecated. So all applications which used event stream get the deprecation warnings. What started community investigation and finally ended with catching the dependency poisoning attack. But please be aware that such attacks can happen in any dependency of the dependency. For example, as you can see, the event stream in latest version has just 7 dependencies. However, there are other packages like, for example, Express framework, Express package, which contains much more dependencies. So if you're using Express framework in your application, then a malicious code can be injected through one of those dots, which is pretty scary. Regarding defense, there are available various tools which tracks any vulnerabilities in dependencies. The most popular commercial ones are Snake and Black Duck, and the open source version of such monitor is OWASP Dependency Track. You can also run npm audit fix to detect any known vulnerabilities before releasing the application. Okay, time for the next Bob challenge. Only some extensions should be scanned. So Bob again searched through the internet in search of the proper regular expression. He combined few of them, and after several tests, it seems that everything works good. So let's analyze this regular expression. As you can see, the word test correctly doesn't match. The word test PDF also doesn't match, which is good for Bob. However, if a file will be named like multiple A characters, then something bad happened. The catastrophic backtracking. Now, what it is? Let's go to the regex debugger. So if there's no match after analyzing whole string, the regex engine goes back to the previous point where other decision could be made and keep searching. If there's again no match, then the regex engine again goes back and makes different decisions. So the amount of those decisions raise exponentially. The thing you should know is that most of regex engines support backtracking, however, not all of them. For example, in Go language, the regex engine doesn't support backtracking, so such RDoS attack wouldn't be possible. If you're using the serverless framework, then the default timeout for your Lambda is 6 seconds. And this limit can be extended to 15 minutes. What happens sometimes in testing functions? What you should know about pricing is that you are built not only for amount of requests, but also for the computing time. And the price depends on the amount of allocated memory. In case of serverless framework, it is by default assigned 1 GB of memory. So if an attacker uploads the 100,000 requests and each is built for 900,000 milliseconds, then you will be charged for 1,500 of US dollars. So for example, as you can see my screenshot from CloudWatch logs, if the attacker uploaded the file called abracadabra for 100,000 times, then it would cost 1,500 US dollars. If you are unsure regarding your regular expression, it's always a good thing to check them against RDoS attacks in many online tools, like, for example, the RDoS checker search.sh. It is as simple as pasting the regular expression and click test. So just a good practice to check your regular expression before using them in any code. What else you can do is adjusting Lambda concurrent execution limit and throttling, and also track any anomalies in logs. For example, in AWS, there's a quite new feature in setting up a billing alarm. So this new feature is called Anomaly Detection. So if your if your Lambda works on, for example, is billed like $100 per month, and then you are charged like $150 after 1 day, then something bad is happening. So this billing alarm will notify you about this abnormality. Okay, time for the third Bob's challenge. So the Lambda function should create a new entry in DynamoDB. So what Bob thought is, somehow you have to pass the connection string to the Lambda. And those connection strings you can put, for example, in environment variables. So here you can see that the username and the password to the DB is in the plain text in environment variables. What you should know is when you are deploying your application using serverless framework, all the CloudFormation templates are going firstly to the newly created S3 bucket. And this S3 bucket can be read by anyone in your AWS account. So for example, if other IAM user lost his keys and the attacker gained permissions just to read S3 buckets, then he can access it and read all the secrets. The only bucket policy that is created by serverless framework is to deny any connections via HTTP. But there's absolutely no protection against accessing this bucket by any other user from your AWS account. So here's the list of all the versions of your application deployed by serverless framework. And when you go in one of such directory, then an attacker can read all the secrets by simply downloading them and reading the secrets. And if you are an attacker with such access to such bucket, then I recommend you to go through all the versions of the Lambda, because even if the latest version has encrypted environment variables or there are no secrets at all, then there's a possibility that in the previous versions you will find some valid secrets. What can you do? Of course, you should encrypt secrets. For example, in AWS, you can do it via KMS service, and you can store those secrets in Secret Manager or SSM parameter store. And in your serverless configuration YAML file, you can refer to those secrets via the following schema. So as you can see, there's the path to the password in parameter store, and then you are adding the value true to decrypt this secret, and then it can be used by your Lambda. The fourth challenge of Bob is creating the POC app where candidates can submit their CVs. So Bob created something like this. There's a place to put a link with a doc file to your CV, and then it is read. It is then converted by Lambda to the plain text from the doc format. Okay, so once I submit it, then we need to give a time. Okay, and there's the confirmation of submission of your CV and however, if you add the semicolon, you will see that this is in the error message that you actually have the remote code execution there. So there's the curl method which downloads the doc file to which I provide the URL, and then there's used the cat.doc program to convert the doc file into plain text. So what attacker can do? Well, as you remember from the beginning of the presentation, he can, for example, display all the environment variables. There are some errors. However, at the end, you can see that there are all the secrets that attackers want to get. So the AWS session token, AWS access key ID, and the AWS secret. So using all those three components, now the attacker is able to do some malicious actions inside of your AWS account. So using the vulnerable Lambda, it was possible to read the access keys, and then using those access keys, an attacker can do malicious stuff under your AWS account, and it depends on what permissions you assign to this execution role. But the problem is, what if you can access resources only from the Lambda? You have to know that the only place to write in Lambda environment is actually the TMP directory. So there is no way to overwrite the Lambda code and then use it again. So what can be done? Let me show you a simple demo. So here I'm using burp proxy and the same application, which is, by the way, the serverless hackme. So you can play with that by yourself. It is available online, and I totally encourage you to access it. You can just Google the serverless goat. But here, let me show you. So of course you have to encode the payload. Use the URL encode, and if you are listing files in a var task directory, then go to the API gateway, and you can see that there's the index.js file. So now let's read this file. So you can use simple program like cat to print out the vulnerable Lambda function code. And here, as you can see, this Lambda function uses the DynamoDB, and there is the table of DynamoDB. Now, if you remember, this is the Node.js execution environment. So what you can do is simply use the command node with the e parameter, and then put your malicious code, your malicious payload. So here I'm simply using the scan method in DynamoDB to dump all the content of the table. Of course, you have to URL encode it to make this a valid HTTP request. And then if you follow the redirection, you will see printed content of whole table. Once again, I totally encourage you to use it by yourself, to play a little bit with that. And you can do it by searching for serverless goat, or simply go to serverless hack me, and there's waiting for you the vulnerable Lambda function code. The over-permissive execution roles are the most common problem in serverless applications. And sometimes it is not because developers are lazy, but because the serverless framework works like this. So by default, in serverless framework, there is option to use only one shared function IAM role. So let's assume that your application, your serverless application, uses actually 3 Lambda functions. And if one of these Lambda function requires permissions like to DynamoDB or S3, if you are using just one role, then if the third Lambda function is vulnerable, it will still have access to the role and to the permissions that actually it doesn't require. The solution is to use per function IAM role. So you have to install a dedicated plugin, which is called the serverless IAM roles per function. And then you can create in the serverless YAML configuration file, you can create a role, a separated role for each function, which from the security point of view is what we want. Regarding defense, obviously follow least privilege principle. Do not use the wildcards and use only those permissions which are required by your function. Furthermore, use the serverless IAM roles per function, which allows you to create the IAM role per function. And the next interesting thing is the API gateway, which is very often used in serverless applications. So the thing you have to know is that there are limits in API gateway, and the interesting part is that this limit of 10,000 requests per second is shared per all your APIs in the entire region. So imagine that you are using the region and one account for multiple applications. Then you will DOS your applications, but your users will DOS your serverless applications. So you can, of course, you can adjust those throttling limits, and you should do it before releasing it. Furthermore, there's something called API Gateway Request Validation, and there's even the plugin in serverless framework. So using this request validator, you can define a schema of the proper request. So for example, regarding this particular example that we went through, you can adjust the schema to have, for example, that the parameter of the URL have to be the valid URL, and you cannot put like the node code there. And last but not least, in the beginning of internet, many server rooms looked like this. And when we migrated to cloud, I think, this is my personal opinion, that we still have the same behaviors. So when I'm doing the cloud security assessments, I see a lot of some dangling Lambda functions, some dangling test resources, which nobody is no longer using them. However, they are still there and awaiting for the attacker. And I know this from my personal experience because when I'm doing my tests on multiple AWS accounts, it happens to me to forget about removing some resources. Of course, it would be better to use the CloudFormation templates or Terraform, but when we are doing something just for test, just as a proof of concept, then it's much easier to do it manually. And if you're doing it, then I recommend you to use AWS Nuke. So in AWS Nuke, you can whitelist which resources shouldn't be removed, and all the other resources are removed by AWS Nuke. So now I'm using this tool quite often, always after work with AWS, and totally recommend you the same approach. So let's sum up what we went through. So there are at least several ways how an attacker can put a malicious code in the serverless applications. First of all, it can be done via the dependency poisoning. Furthermore, there are some ways outside of AWS that can allow you, for example, uploading a file. There's the vulnerable regular expression, so you can do the denial of wallet attack. Other thing are the leaks over the unprotected buckets, or sometimes in the error message, the developers forget um, about removing the environment variable from the stack trace. So if the attacker is able to execute to display the stack trace with the environment variable, that is a big problem for you. And finally, we were talking about some remote code execution in serverless applications and the problem of over-permissive roles, which attacker can use to further penetration of your AWS account. So this is it. I would like to encourage you to contact me if you have any questions regarding with cloud security. Please don't hesitate to contact me. I'm also available on Twitter and LinkedIn. Here you have the links. I hope you liked my presentation. So, are there any questions?